These are a lot of fun, right?
Yeah, very good.
Here's the funny thing is, no one punched him, but Colin's wondering why this is hard, right? And then everyone, not everyone, but a lot of people are like, I've never seen anything this difficult in my entire life. Like, we get all types, and look, this can be hard. It can be easy. It just is up to whether you are getting this, and you will all get it. I'm very confident on that because this is very normal. The only thing abnormal is probably that Colin got it so fast. All right, so let's at least celebrate. Who was able to balance the reaction correctly? Raise your hands. Yeah. Okay. That is 100% of students are at least proficient in balancing if I give you the formulas, right? Not the words still. But we'd have a steep drop off if we did that. All right, let's celebrate. How many of you were able to realize that aluminum hydroxide was the precipitate? Raise your hands. All right, that is 100%. We are killing it so far. All right. Now, the blue boxes in the way I've done this, those are the things I will be looking for to grade on your test. So I guess I didn't put the balance reaction, but that is also one. All right, how many were able to correctly identify sodium hydroxide as the limiting reactant? Raise your hands. All right, we lost 2 people there. That's trouble, but 90% is better than 20% of people, right? Okay, now I would encourage you to stop finding the limiting reactant the way I taught you to. Why? It's long. Now, why was I a moron and taught you the long way?
Because the long way works.
Yeah, the long way works, and we were already in grams and had to find the grams of everything. So I used grams to teach you how to find that limiting reactant. But when we get into volume and molarity, it's pretty simple to just convert them both to moles because you got to do that anyway, right? All right. So what I did right here in the AP test, the test I give you, it will ask you to tell me the amount of moles of everything in the reaction. All right? And the typed up part of this problem did say that. So I took the volume and I multiplied it by molarity. I saw some very smart people make a pretty easy mistake here. So let's just double check that you can do this part. It's really common to forget that the M is actually a proportion itself. So this right here is the result of a short picket fence where I put my loaner on the top left. That is the volume. It's 0.3 liters. Oh my, that is super ugly. I wish I could just change the standard one here. 0.3 liters of this, right? And 0.6 capital M actually means 0.6 moles on top and 1 liter on the bottom. That's where I got the 0.18. Are you okay with that? All right? So that's where the 0.18 came from. Does everyone know where the 0.54 came from? Okay, good. Since I have a 3 right here, for every one of these compounds, I have 3 times the amount of NO3. All right? I would certainly, if any of these didn't make sense, write a note to yourself that says, hey, this wasn't a number he pulled out of his head. It was a number that he multiplied this by 3 because it was a 3-to-1 ratio. All right, so that was the initial moles of aluminum and nitrate ion. Then I did the same thing here to find the original moles of NaOH. I took my volume And look, I didn't do a picket fence, but I kind of did. This is mole, this is liter, right? Like it's there. We're just going faster because it's always the same. You take your volume, multiply it by your molarity, and those are your moles. Now this time they are both the same value because it is a 1 Na to 1 OH ratio. It was that easy. All right, now, to determine your limiting reactant, this one's pretty reasonable to think through. If you just kind of think of this idea, for this reaction to happen, you must have 3 times the amount of NaOH as AlNO3,3, right? So right here, the limiting reactant. NaOH is the limiting reactant because 0.04 is not 3 times bigger than 0.18. Does that idea make sense? You are given 0.04, 0.18. You need more of this in the first place, and I gave you less. So this obviously had to be your limiting reactant. Do you see how much faster that is? Now you can convert to grams. That's fine. You do have to convert to a gram later for one. But on these molarities, you can usually figure out the moles pretty quick, and you can do that comparison. And always just ask yourself that question. Find the one with a bigger coefficient, find your number, all right? And then just ask yourself, is this number, 0.04, 3 times bigger than that number? If the answer is no, then that's your limiting. If the answer is yes, then the other one is. All right. So far, how many were able to correctly identify the amount of moles for all 4? Okay, so the train definitely went off the tracks on that corner. All right? So make some sort of note to yourself how we found these. Because look, you're going to have to study these either tonight or over the weekend, whatever, and without words that you wrote to yourself, numbers are meaningless. Like I took a picture of this because I'm weird. This is when I did it, and I thought of all the things that kids might have questions on. And so I took a picture of it and I put it on Instagram. I said, isn't AP chemistry fun? No one has responded fluorine no yet, but maybe they will. That's not funny. Anyway, see the little arrows and the whatever? Without those, you might be lost. And the people on Instagram or whoever would even see that picture, are they going to even know what they're looking at? Most likely no. It's completely foreign to them. All right? So tell yourself, I found the moles by multiplying the volume and the molarity. That's what we do every time. If there's a subscript, you have to account for the subscript by multiplying by it. All right. Now, another thing that you would be asked on the test, hopefully everyone's all right on this one, is the new total volume. Who had 0.4 liters for the total volume? Oh, yeah. Oh, yeah. No? Yes! Yes! I believe we had 100%. All right, that one's not too bad. It was the 2 volumes added together, right? Converted to liters. All right, that's an ugly box, so I'm going to get rid of it. All right, so then you already indicated that you knew the precipitate was AlOH3, right? All right, this number, where did I get that from? By adding up all the parts, right? Aluminum's 27, oxygen is 16, hydrogen is 1. There was 1 Al, 3 oxygens, 3 hydrogens. I add that up and I got 78. And I rounded. I did everything until here in my head. So there's no way I was going to do any decimal in my head. All right. So then, how many of you correctly identified the mass of the precipitate as 1.04 grams? Raise your hands. Well, that's pretty good. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Wow, I would have thought that'd be a lot smaller. Not hating on you, but that's a good sign. Because if you did that right, that means, hey, I was able to identify the moles of NaOH. I was able to set up a picket fence in the right way, and I was able to find this mass correctly. Did we end up figuring out what you did wrong, Garrett? Did that work when we put the 0.4 on top? Okay, sounds good. All right, so then we're finally to where it gets, well, honestly, 3/4 of these are not that hard. The fourth one is. All right, we get to our spectators, and I know maybe the notes went the other way around. I don't care what order you go in. The concentration of the spectator ions, so NO3 minus is always a spectator ion, and so is Na plus as long as they were both solutions. All right, and these were. So I take its original concentration, not concentration, sorry, its original amount of moles, and I got that from way up here, right? Right here. That's why I ask you for these. Like, I ask you the questions in order, and you'll almost always use something later from the answer you just had to find. So I took that 0.54, I put it over my new volume, and I got 1.35 capital M's. How many had the NO3 was 1.35? Raise your hands. Okay, that's the majority. No, Jack, you're out now. You had it eventually. All right. Then Na plus is 0.1 because it was 0.04 and we had 0.4 on the bottom. Who had that one? Same group of people. And then how many were able to remember that if it's in the LR and the precipitate, it's 0? Raise your hands. Okay, so almost everyone had that one right. All right, then the good news is you can get this last one wrong and still get an A on this test. All right, if you got that far, so far correct, you're probably going to rock this test. Because some of you aren't going to get it balanced correctly, sadly. And then everything's just a waste of your time. What's the charge of silver, everybody? 1. Don't do that to me again. Remember that last test? It's a 1. All right, so the concentration of the excess and the precipitate is found using the idea that you take your initial moles, and you subtract your used moles. And this is where I made a mistake. For some reason, I had 0.133 if you have the version that I have fixed in pen, not 0.0133. All right. So our initial moles we found up top, that was not very difficult. It's 0.18. And we're talking about aluminum, by the way, because it's in the precipitate, and it was not the limiting reactant. Okay, now to find the used moles, we always start everything with our limiting reactant. And if we're in moles, then we've already eliminated one part of the picket fence. All right, so we have 0.04 moles of NaOH. To get rid of moles of NaOH, I have a 3 mole NaOH on the bottom. Where did that 3 come from? The coefficient from the very top. I have a 1 in front of AlOH3 from the coefficient on top. Now, when I originally did this, I didn't have this part. This part is absolutely necessary, but it really wasn't for this one. But let me explain. I'm solving for just mole A plus, right? So for every 1 mole of AlOH3, I have 1 mole of Al plus. This step is only necessary if the first thing has a coefficient. But I would still do it just so you don't fall into that trap. This one, it ended up being 1/1, so it wasn't a big deal. Anyway, we end up with 0.0133. Pretty sure my calculator I just typed 0.4 divided by 3. That's why I got 0.133. All right, now this little arrow is indicating this is the amount of moles used up from the amount of limiting reactant present. So now we take the initial, we minus the used, and we get 0.167 excess. and a lot of you might end there, and you're really close, but you're a little bit wrong. That now is divided by the new volume, and you end up with the concentration being 0.413. And you said it was 418 for you guys? I don't know. 417, whatever. Did I write it down? Did you have 0.413? Okay, probably, I'm guessing he had more numbers after the decimals, the only difference. Yeah, it's fantastic. All right. How fun was that? I know I had fun too. It took me about 20 minutes to do this, maybe. I only got interrupted by Goddard a couple times, which is fine. All right. How many feel terrible about this still? Wow, that was fast. You tore your rotator cuff getting your arm up that fast. Don't spit. All right, here we go. There's plenty more of these to do. This one sucks. So I'm not going to make you do that one.
Oh, okay. How about his one on the test?
It's not. The one on the test, all I remember is it has silver in it.
Oh, okay.
Which is what charge?
+1.
+1. How about this one? Doesn't look very hard.
Here we go.
Okay, go ahead. Round 2. I don't know if I have the answers to this one.
Well, that's nice.
Oh, I have it copied 3 or 4 times. Okay, give this a shot.